Thank you. My name is Carsten Rode. I would like to acknowledge my co-authors. One of them is Jørgen Erik, who is here with us, and they will take over from half of the presentation. And the final one is our external lecturer, Claus Simonsen. I should say already here, he's an architect. He has a normal design practice where he comes normally, and then he comes into DTU and teaches this course for us on a regular weekly basis. Jørgen Erik and myself, we are civil engineers and have specialized in energy design of buildings. That's our background. This is a story about how we have implemented the CDIO process in the Bachelor's of Engineers program here at DTU. We started in the fall of 2008, so we've tried it now for 6 semesters, for 3 years, if you will. It used to be that we have a lot of mathematics and physics courses in the beginning, in the first semester for the students when they came here. They come normally directly from high school, but we tried to, with the CDIO process, to make a more inspiring teaching environment for the students. So as part of that, and that's the main theme of this talk today, is the design build course that we then implemented in the first semester instead of the program, as you can see, that was in the past. The idea was that this design build course should be a supplement to one of the more, let's call it a little bit theoretical courses we had in the beginning of the program for the students. I can also tell already here that the Bachelor's of Engineers program at DTU, it's a 7th semester program. They come for half a year in the 5th semester into a design practice or practice outside of DTU. But the first 4 semesters is kind of their starting up of their study. And the CDIO program at DTU is implemented mainly for those first 4 semesters. And this is then the very first semester 1 out of those. And we used to have our building energy course taught in the 3rd semester. It's not such a rocket science course, but you make some basic mathematics that you can do already with your skills from high school. So we thought that would be a course we could move to the 3rd semester, or sorry, from the 3rd to the 1st semester, to be a supplement to the design build course. So a motivation, why should you learn these calculation techniques over here? Well, that's because you need them when you make your design build course. That was the whole overall plan. So we tried to make something new. We are civil engineers, so we were looking to who else has tried this CDIO process in the civil engineering business. And that was not so much we could look to. There were not so many courses we could steal, like we heard in one of the previous talks that you could. So we had to invent something. So it took us a little bit more than a year. We started in spring 2007, a year and a half before we had to teach this for the first time. And we were sitting in groups, colleagues, and discussing how can we do this, and which course also could we take to be the companion course to the design build course. So this course, I was one of the teachers in our building energy course, so that's why I got involved. And we said, okay, let's make an example of how this can be used in this context. So the students should calculate energy consumption for a small building, but first of all, they should learn, and that was the main idea we invented for this, why do we live in buildings? Why do we need a thermal or building envelope, a climate shelter, if you will? Such questions could be asked to the students, and then for themselves, again, as we've heard before, no textbooks, figure it out for yourself, why, what is the solution to this? Well, you could say it's an easy question because I guess in Denmark, as most other countries, our students, they live in buildings already, in dormitories or with their families or wherever with their parents. So they had something to look for already. But now we made them think, why do we live in buildings or go to school, work in buildings? And what is the necessary prerequisites to make a building? So they had to conceive this idea. They are giving a 45-minute lecture in the beginning, asking this question, showing them a lot of arbitrary pictures of arbitrary buildings, and make them start the process of thinking. For many of them, they come here on the very first Monday, the first day in their study at DTU. They come directly from high school. They have no prerequisites whatsoever. And they are not used to this form of teaching. The high school is the complete opposite. Textbooks and very well-defined curricula, they know what to do, and they have a teacher who guides them through this. So that's the idea. But they pose this question, conceive this idea. We are teaching in DTU, our semesters are for 13 weeks. So roughly we have 3 weeks to each of these things here. So 3 weeks to conceive the problem, to design a solution for that, 3 weeks to implement it, and 3 weeks to operate. And already here you see some pictures that illustrates more or less the rest of the presentation here, that they're actually gonna make a building themselves. That was the question that they were posed, what is it that we need. So they were asked to make a model house. Of course, we cannot afford to make real houses in the full scale, so make a house of some form in the scale 1 to 20. We'll provide the materials. They got a small budget for that. And we have a teaching assistant with whom they can make discussions, ask questions, and who also helps them to provide building materials, so for the practical reasons. We provide for them a small control and measuring unit that could heat the building. So they're asked to heat the building to normal desirable indoor temperature and measure the associated energy consumption. So that measuring unit was supplied. They did not have to design that part. And then the houses were going to be put outside in the outdoor environment here in Denmark. We put them on the soil, on the ground, on a plate of polystyrene. So that part of the heat loss they should not be concerned with. But then they should think about how to make such a building, so the geometry, many of them also because we have an architect, external lecturer who sees them on a daily basis. So all these architectural, the geometry, the design of the building in that form is very much some of the things that they think about. Some of them even think about also how the appearance of the building, and they put flagpoles in the garden as they make it on the polystyrene board. Materials to be used, what are there? Of course, we have to limit ourselves to materials we can have down in the scale 1 to 20. So not all materials are that easy as it comes. Insulation thicknesses, windows, how do they perform? They have bigger heat losses, but also provide some solar gains that they can think about. And then and that's the companion part to the, let's call it theoretical course, that they should make on their own in a small scale a design calculation of the expected heat loss of the building once it gets heated to, let's say, 20 degrees centigrade. And then they should make a halfway report based on their calculations and their designs. So that completes the design phase when it comes to that. Then we go to the implementation part, and that is to make the houses. So we have a laboratory where they can, a workshop where they can do this. And as I said before, the teaching assistant will help them to make it possible to really acquire materials and to assemble them in a reasonable way. We see some more pictures. And they are playing, it's fantastic to play and to make a smart design and to make it look good, but also to work technically in a proper way, because as we heard before, it's required that they're successful. They have to make a house, they have to have something to measure, otherwise they cannot pass the course. And they also grade it, I should mention. So there is some motivation to do it in a good way. But then finally in the operation phase, and normally we have 120 students. 8 of them we have in the fall semester, 40 in the spring semester. It's mainly good for those who have the course in the fall, because once we get to the end of the semester, we are in November, and then it's cold outside, reasonably here in Denmark, and then it makes sense to heat the house to 20 degrees and to measure how much heat is given by the electrical heater. And then to measure, of course, the temperatures, and finally, that's one of the key points, of course, to make a comparison between what they measure and what they had calculated in the first half of the course. And then, of course, to report it and to also give some talks to each other where they present their findings and their results. So more pictures, and I think now Jørgen will take over, because Jørgen has then also been involved in making some evaluation of how good a form of teaching is this, apart from our standard evaluation that we ask our students here at DTU always to fill in. So please, Jørgen.
Here we just have some few pictures more. We had this measurements where we were putting heat into the room, and we had a little ventilator here, and you can see we had a lot of lines going into the house, so we could measure for each house. Then we also made a kind of a study about how the students, how satisfied they were. There was both a paper inquiry, because when you do a paper inquiry, you can actually somehow force the students to come. We said that they had to come this specific day in order to, they had to do an assignment, and they were forced to do that, and then we can control that all 100% participating there are putting in their votes. When you have the electronic inquiry, you quite often have a quite low response because they are so much used to so many responses to 6 courses every semester and things like that. Some of the questions we have, like 4 and 5 is highest score. 1 is negative statement, 5 is positive. And as you can see, probably all of you are familiar with getting responses from your courses, and you're not always too happy about when you see it, and you wonder, oh, they are so nursed all the time, and they're so, sometimes it's not so nice to see it. But you see in this case that we actually get very good feedback for the course, since 75% actually gave the highest score 4 and 5, which is very satisfying. And that's if the project makes you commit yourself, so they were very committed to this project. And also, did the teaching method of this course motivate you for added interest for studying to construction engineering, which is actually quite important since this is the starting part of the study. And you also see here that 74% gave a score 4 and 5, so that is also a very good result. And how was the teamwork in your group? And also in this case, you can see this is a kind of a teamwork. You really trust your company when somebody's hammering down there. So 72% was very satisfied with this. And I think one of the really important things when you're talking about engineers, we all know that it's hard to get the women into engineering fields. And I think I also had some experience from when I was studying at the Oslo University College, where we have an energy and environmental resource line where it was much more project-based, and we have a lot of women on that line, the highest up at Oslo University College. And also in this, you see that the women here are very satisfied with the course as well. And we also here at DTU Building Engineering, we have a integrated, we have a design build, architectural design study line, and nearly half of the students there are women. So I really think that when we set up our curriculum as in many cases men, we somehow should integrate the women much more in order to get women interested in engineering, because actually they are interested in engineering fields, but not maybe the way we men set it up with all this endless lectures and all this kind of traditional teaching. Thank you very much for your attention.